All right, here is 6.2 using a model to solve equations. I'm going to use this balance model. So here's a balance. Essentially, this middle is where your equal sign is, and everything to the right of the equal sign, so this 5 up here, needs to go on the right side, and everything to the left of the equal side needs to go to the left, and what's going to happen is it'll be balanced. So if I look here, I have an x and I have a plus 1. So let's put an x on the left and a plus 1 on the left. Notice that this goes down because it's heavier. It'll go down. And on the right side, to balance it, we need to put 5 plus 1s, which is the same as 5. 5 and x plus 1 is equal. And I have my equation, so I'm going to press check mark. Now I need to isolate the x tiles, which means get them on their own. So to get rid of what's over here that is not the x tile, it's this plus 1. I need to get rid of plus 1. How do I get rid of 1? I subtract it. So I'm going to subtract 1. Notice that what I did here also happened to the other side. I subtracted from both sides. And now I've gotten rid of that, and x is by itself, and you'll notice x is 4. So x equals positive 4 is what we'd write next on our next step. Well, check out that sound. Some questions get more difficult. That last question was a one-step equation, so it was just one thing we needed to do to get x by itself, really. This is a two-step equation. You'll notice that there's multiplication happening and there's addition of a negative number here, so there's multiplication and addition, so there's two steps. So let's get this set up. We see 5x, so let's put 5x's over on that left side of the equal sign. And then plus negative 4, so subtracting 4 or plus negative 4, we're going to put 4 negatives over there. And this is the same thing that's up here on the left side. And on the right side is negative 19, so I'm going to click that a few times. And there we go, it's equal. Now that we have that, we are going to isolate the x tiles. We're going to get rid of what's not x tiles over here. So negative 1 and a positive 1 would make 0, so we need to put a positive 1 there, and then do it again. Notice I'm doing it to both sides. Positives are going left and right the same amount, because if you were to add 1 to one side and not the other, it would make it unbalanced. It would tip the scale. So you have to do the same thing to both sides to say that it's still the same, that it's still equal. Now that I've gotten rid of that, what I can do is then I have 5x is equal to negative 15. What I need to do now is divide by this coefficient, this 5. So I'm going to split these x's up so that there's just 1 in each group. And when I do that, I also split it up on the right side. And you'll notice that I made 5 groups. And if I take this negative 15 and split it up into 5, also known as dividing by 5, how many are in each group? There's 1, 2, 3. So it's going to be negative 3. That's my answer here. So x is the same thing as negative 3. So that website I'll put in the description. Here we have an example. It's 3 plus q equals 12. Now, using the models, we'll use this balance. We put a q on this side, and then we have 3 1s over here, right? We've got 3 of them. And on the right side, we have 12, which is the same thing as 1, 2, 3, 4, 5. Skip a few, 12. So we have 12 here and here, and these are all positive 1s. So I'm using integers to make positive 1s right here. And these were positives. Now, to figure this out, we need to isolate our q and get our variable on its side. We're going to take away these 3, get rid of them. And what we do to the left side here, we need to do the right. So we're going to take 3 and get rid of them. And what are we left with? We're left with q equals how many? There's 8 here and 1 more, 9. So it's positive 9 or just 9. So that's how you can use this model. I'm going to do a two-step equation as well. 4d plus 6 equals 10. So I've drawn this out. I have 1, 2, 3, 4 that are d, 4 of those, which represents some number. And then I have 6 positive 1s. Okay, and then over on the right side of my equal sign, I'm going to draw my 10 positive 1s, which makes 10. Now we need to get rid of these from this side. So we're going to take all of these right here, these 6 1s, and get rid of them. And we're going to get rid of 6 1s from over here, get rid of them, and we're left with, If we draw the picture again, what's left over, we'd have 1, 2, 3, 4. D equals 1, 2, 3, 4 positive 1s. Now just to draw the algebraic steps in here, what we did here was we did 4D plus 6, which is what we had, and we subtracted 6. We got rid of 6. And then we had our 10, which is what we had, and we subtracted 6. Okay, so that's what you draw algebraically, the next step. Finally, we have 4D. That leaves us with 4D equals 4. And finally, we need to split up in equal groups. So 1, 2, 3, 4 to make it so that there's just a group with D. And we have 1, 2, 3, 4 that we split up. And we're left with D equals, how many is in a group? Just positive 1. So D is positive 1 in this case. And if we think back to it, 4 times 1 is 1 plus 6 is 10, which is a verified answer. 10 equals 10. You will need to know how to verify your answer, so I'm going to show you that here. To verify your answer, you just take this original equation, but where you have your variable, you're going to put in the number that it's worth. So where this D was in this equation, we're going to put a 1 in there, and then write down the rest of the equation. Then we're going to multiply through and add, follow BEDMAS. 4 times 1 is 4, plus 6 equals 10. 4 plus 6 is 10 equals 10. This is just to check your work that you did this correct. And if you get to 10 equals 10, the same number equals the same number, that would be checked and this would be verified. I forgot to verify on the first question, but most of your questions in your textbook are going to get you to verify. You will get a mark for doing it. So we found that Q was equal to 9. So we need to take this first equation to verify. So I like to write the word verify right above so it's not confusing. We're going to take 3 plus, just write it down. When you get to your variable, just write down the number that it is. It's 9. And then continue, equals 12. And 3 plus 9, yes, is 12. So 12 equals 12. With single step equations, the verification seems kind of silly because it's like, no duh. But when you get to 4 more complicated equations, maybe you're using the ideal gas law in chemistry in high school or something like that, knowing how to do this and verify is a good way to not make a big mistake that, could cause you to use the wrong amount of a chemical and it explode, or or when maybe with money, we use this, maybe there's different values of bills and you accidentally pay too many because you didn't verify that the amount that you thought you had to pay of a certain amount of bill was the right amount. There will be some examples later on in your assignments, not this week, but in future assignments that will deal with real world problems using this math.